Objective of today class is, on the completion of this period you would be able to know inductance, energy stored in magnetic field, and energy stored the per unit value, energy stored per unit value. So this is the main objective, these are the main objective of the today class, main objective of the today class. So here we have to learn about the inductance in circuits, and energy stored in per unit value, and energy stored in magnetic field, energy stored in magnetic field. First we have to learn about the inductance in a circuits. Inductance in a circuits, the inductance. What is the inductance? What is the inductance in circuits? So this is a circuit diagram for electrical circuit diagram. It consists of battery and in series with resistance, and in series with inductance, and in series with switch. So in this circuit it consists of battery E, it is denoted with the E, it is denoted with E, and series resistance, it is denoted with R, series resistance which is denoted with the R. You have to observe in circuit, circuits, electrical circuit diagram, and it is, and inductance, which is denoted with the L, and it is a series, with switch S. So you have to define the inductance. What are the inductance in this electrical circuit, So inductance can be interpreted as measure of opposite to the rate of change of current. The inductance can be interpreted as measure of opposite to the rate of change of current. Okay, now the property of a inductance, to oppose the flow of electric current, So the motion is causes in circuit, So here the remain the resistance. What is the resistance? The resistance is a measure which opposed to the current, is called as the resistance, So resistance is nothing but which oppose the flow of electric current, is called as resistance. So it's the energy stored in magnetic field, To establish a magnetic field, the energy must be spent and next, the energy is supplied to the inductance is spent in two ways. To establishment of magnetic field, the energy must be spent. Okay, now if the magnetic field is there, so here the energy will be spent. And the energy is supplied. The energy is supplied to the inductance. And spent in two ways. So here first the part of it goes to meet I square R losses. Part of it goes to meet I square R losses. Next part B is equal part of it goes to create field. will store in the magnetic field as potential energy, as potential energy, as potential energy. So here to establishment of magnetic field, the establishment of magnetic field and the inductance will be spent in two ways. Inductance will be spent in two ways. The part of it goes to must be losses will be occur, I square r losses will be occur, and part of it goes to create and field it store in magnetic field as potential energy, as potential energy. As a circuit is completed, the current being to increases, but the inductance is produce an EMF that oppose the increasing the current, oppose the increasing the current. That means when switch is the close here, so here the current will be forced, the current is flows through the resistance and inductance, resistance and inductance. So then here a circuit is in this circuit the increasing, okay na, the current will be increasing, so the inductance is produced, the EMF, this EMF is caused to oppose the flow of electric current, okay now. So here therefore the current does not change from 0 to its maximum instant. The current does not change from 0 to its maximum instantaneously. So the maximum current I maximum is equal to E by R. I maximum is equal to E by R, where I equal to V by R according to the Ohm's law. So I maximum is equal to E is the battery and R is the resistance. So the maximum current is equal to E by R. Next, the energy stored in magnetic field. Here how the energy stored in the magnetic field, here. So here consider an inductance L in which we start flow a current I is flowing. We start flowing a current I is flowing. As soon as the current start flowing, the every change of it is opposed by the self-induced EMF. Then the power is needed to fight the back EMF. The power is needed to fight the back EMF. That means here when the switch is the close, switch S is the closing, the inductance is produced, the EMF is induced in this conductor, in this inductor. So that EMF is caused, to oppose the flow of electric current, So here the consider as L inductance, we start the current flowing. As soon as the current is start flowing, the every change of it opposed by the self-induced EMF. Okay now, if the current is flowing through the conductor, the EMF is produced. So this EMF is caused to oppose the flow of electric current. So here every changes of it opposed by the self-induced EMF. The power is to fight back the EMF. So this power is equal to I into V, I into E. I into E. So here the I is the current flowing through the circuit and E is the voltage across the circuit. So I is equal I into L into di by dt, where V equal to L into di by dt. So this is the E means the induced EMF produced in a inductors. So induced EMF produced in a inductors. So the relation between the induced EMF and inductance in the circuit, which is equal to E is equal to L into di by dt, and the L is equal to E by di by dt. L is equal to E by di by dt. So here, so the power is equal to I into E. Power is equal to I into E. So I into L into di by dt. Okay now, where E is equal to L into di by dt is nothing but you have to discuss in self-induced EMF, self-inductance of the coil, self-inductance of the conductor is equal to the induced EMF produced in a conductor, which is equal to the rate of change of current due to the rate of change of current in the conductor. Due to the rate of change of current in the inductors or coil, then the EMF is produced. So this EMF is causes to oppose the flow of electric current. So that is called as the property of inductance. That is called as the property of inductance. That is called as property of inductance. So here the E is equal to L into di by dt. E is equal to L into di by dt. So the power is equal to I into L into di by dt. Next, calculate work to increase the current from 0 to I with respect to time 0 to t. So that means the work will be done in an electrical circuit. So which is equal to the integration of 0 to t, into P into dt, where P is the power. So here the which is equal to integration of 0 to t I into L into di by dt, So I into L into di by dt is equal to power. I into L into di by dt is equal to power. So here the work is equal to integration of 0 to t. So here the L into di by dt, L into I into di by dt. So L is a constant parameter. So it will be common. So here the integration of I into di. So then we have integrated to it one. Then we have to obtain the half Li square. Half Li square. So the energy stored in inductors, is W is equal to, that is the work will be done in an electrical circuit. W is equal to half Li square joules. So this is the energy stored in magnetic field. So here we have to observe this one. Here this is the electrical circuit is there. Here let me explain just briefly here how it can be produced, how the energy stored in the magnetic field, how the energy stored in the magnetic field. When switch is the closing of this electrical circuit. So this you have to observe the electrical circuit. So here the current will be flows from the battery to the resistance and inductance. So the inductance store the energy. So here how the inductance will be stored. So how to work will be done in these circuits. That is E equal to half Li square. We have to discuss now. Okay now, but how it can be possible? Okay now. So here when the current will be flows through this circuit. Okay now, then the induced EMF is produced in this coil or inductance. Okay now. So this EMF is caused to oppose the flow of electric current. This EMF is caused oppose the flow of electric current. So here that induced EMF is equal to L into di by dt. L into di by dt. Okay now, where L is the constant parameter, that is the L is nothing but constant parameter. So here the L is inductance of the coil. So the EMF is nothing but the rate of change of current. So here the E is equal to L into di by dt. Okay now. So the power of this circuit equal to P equal to V into I, where V is nothing but E, that is the induced EMF produced in an inductors. So here the power is equal to I into E, where I is the current flowing through the circuit, the E is the induced EMF is produced in a inductors. Then we have to substitute in this equation E is equal to L into di by dt. Then we have to, the power is flowing, then the work will be done in an electrical circuit. Then we will get half Li square. Half Li square. So this is the energy stored in the magnetic field. So some problem given here. First problem we have to observe this one. A 24 volts battery is connected in series with a resistors and inductors. So we have to observe the circuits. Okay now. A 24 volt battery is connected in series with the resistors and inductors, where the resistor R is equal to 8 ohms. And the inductor L is equal to 4 Henry. Find the energy stored in the inductor when current is reaches its maximum value. Then here we have to observe from this problem. We have to given data. We have to observe the given data. What are the given data here? We have to observe. So the voltage is given. Here. So the voltage V is equal to 24 volts. Okay now. So here a battery is connected, 24 volts battery. Okay now, 24 volt battery is connected in series with resistors and inductors. So here the voltage is equal to 24 volts. Next, resistors and inductors. So the resistor value is equal to 8 ohm and inductor value is equal to 4 Henry. So what is the energy stored in inductors? Okay now, the current is reaches the maximum value. So here we have to remind the energy stored in the magnetic field. What are the energy stored in the magnetic field? That is E equal to half Li square. Okay now. So here the only thing is nothing but unknown. The equation is above circuit current. Okay now. Here the inductance is there, resistor is there, voltage is there, but we don't know about the current. So then we have to maximum current means I maximum. So here the voltage also is maximum. Then the resistance. Okay now, from the resistance and inductance we have to find from the value of given, the resistance value is given and battery voltage given. Okay now, from these two, okay now, then we will find the value of current in the circuit. that the I maximum is equal to V by R. I maximum is equal to V by R. So here we go to 24 volts. The R is equal to 8 ohms. Then we will get simplify of this equation. We will get maximum current equal to 3 amperes. Okay, now so here the inserting in this into the above expression. Okay, now that is the energy stored in the magnetic field, that is E equal to half Li square. So the E is equal to half into L equal to 4 Henry, and the current I is equal to 3 amperes. Then we will get 3 square 4 into 3 square 4 into 3 square. So here the 4, the 2 to the 4. So here 2 into 9, that is the 18 joules. 18 joules we will get the energy stored in the magnetic field. So this is our last problem. Next is second problem. Second. Here an iron ring of 20 centimeter mean diameter, has a cross section of 100 centimeter square, is wound with 400 tons of wire. Calculate the existing current is required to establish a flux density of 1 Weber per meter square. If the relative permeability of the iron is 1000, find the energy stored in the magnetic field. Okay, now so an iron ring of 20 centimeter mean diameter, has a cross section area of 100 centimeter square, is wound with 400 tons of wire. Calculate the existing current is required to establish a flux density of 1 Weber per meter square. If the relative permeability of the iron is 1000, find the energy stored. From the above problem, you have to observe the given data. So here the given data, here the D is equal to, diameter is given, so D is equal to 20 centimeter. So the centimeter is converted in a meter, then we will get 0.2 meter. Next, the area of cross section is equal to A is equal to 1000 centimeter square. Next, number of tons is given. Number of tons is equal to 400 tons. Next, the flux density. Okay, now the flux density of is equal to 1 Weber per meter square. And the relative permeability also given. The relative permeability is equal to 1000 tons. Okay, now so here from the above problem, the mean length of iron ring is nothing but pi into 0.2 meter. Iron ring. So the area of, that is the length of iron ring is equal to pi. Okay, now pi into 0.2. So here the ring diameter is given. but not length is given. So then we will get the length is equal to pi into 0.2. Okay na. So the relation between the diameter and the length is equal to L is equal to pi into d. So here pi into 0.2, then we will get the length of the ring. Next, here ampere turns is given. So the relation between the ampere turns and maximum flux density and length is nothing but Ni is equal to h into length, where h is the magnetic field intensity. So the relation between the magnetic field intensity and density, okay, which is equal to B by mu naught into mu r into L. So then we will get B equal to maximum flux density. Okay, flux density of the field is equal to 1 by mu naught into mu r. Mu naught is value equal to absolute permeability, mu r equal to relative permeability value. So here the absolute permeability value equal to 4 pi into 10 to the power of minus 7, and the relative permeability value equal to 1000. And length, okay, now length equal to pi into 0.2. Then the ampere turns is equal to 500. Okay, now ampere turns equal to 500. Okay, now so from this expression, then you have to calculate the value of I. Okay, now I equal to n into I by n. So where n is the number of turns, 500 turns. Next, number of turns, okay, now wound with the turns, equal to 400. Then we will get 1.25 amperes. So we will get the current. Next we have to find the value of inductance. Okay, inductance of the iron ring. L is equal to mu naught into mu r into A into n square by I. So you have to substitute the value of mu naught value 4 pi into 24 of minus 7 into mu r value equal to 1000. So 24 of 3 into area of cross section 1000 into 24 of minus 4 into n square 400 square by length 0.2 into pi. Why? Because here iron ring is there, so 0.2 into pi. Then we will get the inductance value is equal to 3.2 Henry. So we have to find the value of inductance. Next, what is the value of energy stored? In magnetic field? The E is equal to half into Li square. So here half into inductance value equal to 3.2. Half into inductance value 3.2 into I square 1.25 square. Then we will get 2.5 joules. That is the energy stored in the magnetic field. The E is equal to 2.6 joules. We have to calculate the value of energy stored in the magnetic field equal to 2.5 joules. Next, energy stored per unit value. Consider a coil n number of turns wound over a circuit. The length of L meter and uniform cross section area of A meter. Okay, na A meter square. Next, from the analysis of energy stored in the inductors, so the E equal to half Li square. So here the energy stored, the parent value, energy stored, the parent value is equal to, okay na, half Li square into A into L, okay na, Li square by 2, that is the half Li square into AL, area of cross section, where L is the length and where capital L is the inductance value of the conductors. So from this expression we have to find the L is equal to mu naught into mu r into n square into I square by 2 into L square. So here from this expression then we will get H equal to n into I by L, okay, H to L into L by L. From this expression B is equal to mu naught into mu r into H, the relation between the B and H. So then we will get the B square by 2 into mu, B square by 2 into mu. So this is the, so the energy stored per unit volume in the magnetic field is B square by 2 mu, B square by 2 into mu. So this is the energy stored in per unit volume. So in today's class we have to discuss about the energy stored in the magnetic field. So okay, W is equal to half Li square and energy stored per unit volume is equal to B square by 2 mu, B square by 2 mu. Some quiz question is given here. The energy stored in the magnetic field is, the energy stored in magnetic field is directly proportional to current, and option B is nothing but inversely proportional to the current. Option C is nothing but directly proportional to the square of current. Option D is nothing but inversely proportional to the square of current. So here the option C is correct answer, directly proportional to the square of current. Next, second question, second bit. Energy stored per unit volume. Energy stored per unit volume is nothing but option A is called B square by 2 mu. Option B is called half L square. Option C is equal to half LC square. Option D is none. Option D is none. So here energy stored per unit volume is equal to option A, B square by 2 mu is called as correct answer. Okay na, A is equal A, option A is B square by 2 mu is called as, which is the correct answer, which is the correct answer. Next third bit is the problem is given here. Inductance value, okay na, and 8 Henry choke is carry a current of 8 Henry choke is carry a current of 500 ampere, 500 milliampere. The energy stored in magnetic field is, the energy stored in the magnetic field is, the energy stored in magnetic field is how much? That is the half Li square, half Li square. Okay now you have to calculate the value of half Li square. E is equal half Li square. L is given 8 Henry. 8, okay now half into 8, that is the 4 into 500 into milliampere means 500 into 24 minus 3 into square, 500 into 24 minus 3 square, then we will get the correct answer. Okay now we have to find this problem. Some frequently asked question is given here and problem is given. We have to follow, we have to practice it, we have to practice it. Okay, thank you.